Okay, very similar to the sine function, when we're looking at cosine, specifically ArcCosine or inverse cosine, well, the cosine function is a function, but we can tell by the horizontal line test its inverse is not a function. And so when we're thinking about the inverse of cosine, we do have to also restrict the domain. So going as close to the origin as possible, looking at those smallest input, in order to get all of the outputs of cosine from a -1 to a +1, we restrict the domain between 0 and pi. Notice how that gets us all of the outputs there. And so when we graph the inverse cosine function, it looks like this. When we exchange the inputs and the outputs, we see that that is our inverse cosine function. And so when we're thinking about inverse cosine, we restrict the domain from 0 to pi. That means that when we're looking at inverse cosine values, when we're thinking about calculating inverse cosine, think about our unit circle. We're thinking the first and second quadrant, that is from 0 to pi. So cosine, inverse cosine of -√2/2, we'll think about that point when the x is -√2/2, and we're thinking inverse cosine, so we're thinking first and second quadrants. It's going to be this point right here. And what value corresponds to this? That would be 3 pi over 4. Imagine a unit circle. That's that right there. Positive 3 pi over 4 to get there. So this is 3 pi over 4. Once again, not just giving exact answers, but we're putting these in radians. ArcCosine of -2, okay? Thinking about it, well, -2 is not between -1 and +1. It's not. So that means that, because that is the input, that is our inputs for our ArcCosine, the outputs of our regular cosine cannot get a -2. It just doesn't happen. So that means this does not exist. Finally, inverse cosine of 0. When is our x value 0 in the first or second quadrant? That is the point 0, 1, and that is the radian measure pi over 2. Pi over 2 would get us the point 0, 1, meaning the x value would be 0. Boom.